I want to make you a short presentation about the preparation, properties, structure and uses of hydrogen peroxide. Dear students, myself Dr. Digna Varghese. Contents of the presentation is hydrogen peroxide, preparation of hydrogen peroxide, properties of hydrogen peroxide, structure of hydrogen peroxide and uses of hydrogen peroxide. Hydrogen peroxide. Hydrogen peroxide is a chemical compound with the molecular formula H2O2. It is a combination of hydrogen and water. Alexander von Humboldt reported one of the first synthetic peroxides, that is barium peroxide, in 1799 as a byproduct of his attempts to decompose air. Alexander von Humboldt, who reported the first synthetic peroxide. The clear liquid acts as a mild antiseptic and comes in various potencies depending on its purposes. If 3% hydrogen peroxide, it is used for household, 6 to 10% for hair bleaching, 35% for food grade and 90% for industrial purposes. So it is an important chemical that is used in everywhere. Preparation of hydrogen peroxide. From hydrated barium peroxide and sulfuric acid. Hydrogen peroxide is prepared by adding an ice-cold aqueous paste of hydrated barium peroxide BaO2 8H2O in its solid form in a thin stream of ice-cold dilute sulfuric acid that will react each other to form barium sulfate that is insoluble, and a 5% hydrogen peroxide is formed and water is another byproduct. So barium sulfate is insoluble, so the 5% hydrogen peroxide solution is obtained as filtrate. Second method is from hydrated barium peroxide and dilute sulfuric acid, dilute phosphoric acid. Hydrogen peroxide is prepared by adding an ice-cold aqueous paste of hydrated barium peroxide, that is BaO2 8H2O, in a thin stream to ice-cold dilute phosphoric acid, and we will get barium phosphate which is insoluble like barium sulfate, and it is filtered off, and remaining solution contains the 5% hydrogen peroxide which is obtained as filtrate. Another method of preparation of hydrogen peroxide is from sodium peroxide and dilute sulfuric acid. This method is known as Merck's method. Hydrogen peroxide is prepared by adding calculated amount of sodium peroxide and in small quantities gradually with a constant stirring to ice cold solution of sulfuric acid, that is about 20% dilute sulfuric acid. The solution is cooled below 0 degrees Celsius when the sodium sulfate crystallizes out as its decahydrate, that is formed sodium sulfate is Na2SO4 10H2O, which is filtered off, and the remaining solution contains hydrogen peroxide. Another method of the preparation for hydrogen peroxide is from barium peroxide and carbon dioxide. Hydrogen peroxide can be prepared by bubbling carbon dioxide through the ice-cold aqueous paste of barium peroxide. We will get barium carbonate and hydrogen peroxide. The insoluble barium carbonate is filtered off to get the dilute solution of hydrogen peroxide. So these are the 4 methods used normally in a lab for the preparation of hydrogen peroxide. Most of these methods involves the reactant as hydrated barium peroxide and with sulfuric acid or phosphoric acid or with carbon dioxide. We will get hydrogen peroxide as product. Manufacture of hydrogen peroxide. First method is from 50% dilute sulfuric acid by electrolysis. Hydrogen peroxide is manufactured by electrolysis of cold 50% sulfuric acid in a cell containing platinum as anode and graphite as cathode. The reaction is involved in the cell is hydrogen sulfate is decomposes to H plus and HSO4 minus at anode, that is at platinum electrode, bisulfate breaks into form H2S2O8, that is peroxide disulfuric acid with the 2 electron. At cathode reduction occurs, that is graphite is the cathode. In that H plus is reduced to hydrogen gas. In this H2S2O8, that is peroxide disulfuric acid, is immediately drawn off from the cell and it is distilled under vacuum when peroxide disulfuric acid reacts with water to yield hydrogen peroxide, which distills over along with water. A 30% hydrogen peroxide is obtained by this method. That is, the method is from 50% cold sulfuric acid taken in a cell, that is breaks into proton and bisulfate ion at anode, that is at the platinum electrode. Bisulfate oxidized to peroxide disulfuric acid with the elimination of 2 electron. This electron is used here in the cathode graphite electrode. H plus electron giving hydrogen, and the hydrogen peroxide disulfuric acid is immediately drawn off from the cell and it is distilled over water to get hydrogen peroxide. This hydrogen peroxide is about 30% hydrogen peroxide. Second method is from an equimolecular mixture of sulfuric acid and ammonium sulfate by electrolysis. Hydrogen peroxide can be manufactured by the electrolysis of an equimolecular mixture of sulfuric acid and ammonium sulfate in a cell using platinum anode and the graphite cathode. Here the cell reaction is like that: ammonium sulfate reacts with the sulfuric acid. We are taking in the cell a mixture of sulfuric acid and ammonium sulfate. We will get ammonium bisulfate. This ammonium bisulfate decomposes to proton and ammonium sulfate ion. At anode, that is at the platinum electrode, ammonium sulfate will give ammonium persulfate with 2 electron. At cathode or at graphite electrode, reduction occurs and we will get hydrogen gas. Ammonium persulfate is immediately drawn out of from the cell and which is distilled over along with water, and we will get ammonium bisulfate and hydrogen peroxide. A 30% hydrogen peroxide is obtained by this method. Third method is from 2-ethyl anthraquinol and by auto-oxidation process. Industrially, hydrogen peroxide can be prepared by the auto-oxidation of 2-ethyl anthraquinol. Here, the 2-ethyl anthraquinol, the air is bubbled through the 10% of 2-ethyl anthraquinol in benzene cyclohexane mixture when it is oxidized to 2-ethyl anthraquinone. Here, the hydrogen peroxide is produced as a byproduct, and we get a 1% solution of hydrogen peroxide. Here we can convert this 2-ethyl anthraquinone back to anthraquinol by reduction using palladium catalyst in the presence of hydrogen. We will get 2-ethyl anthraquinol. That means the step can be reversed by using a reduction method with hydrogen, palladium, in the presence of palladium catalyst. Anthraquinone converted into anthraquinol, and which can be used again for the more production of hydrogen peroxide. Here we will get 1% hydrogen peroxide by this method. These are the three methods used for the manufacture of hydrogen peroxide. Hydrogen peroxide is prepared and how it is stored. Storage of hydrogen peroxide. Hydrogen peroxide cannot be stored in glass bottles since the rough surface of the glass or alkali oxides present in it and the exposure to light catalyze its decomposition. Hydrogen peroxide is decomposed by the glass in that alkali oxides are present. Therefore, hydrogen peroxide is usually stored in colored paraffin wax bottles, wax coated plastic or Teflon bottles. To prevent decomposition of hydrogen peroxide, some stabilizers such as urea, glycerin, acetanilide, phosphoric acid must also be added in some cases. Concentration of hydrogen peroxide. Concentration of dilute hydrogen peroxide by the removal of water in a sequence of steps can eventually lead to a pure hydrogen peroxide. First step is dilute hydrogen peroxide is concentrated to 45% by mass by evaporation of hydrogen peroxide over a heated water bath. Second step is 45% hydrogen peroxide converted to 85% concentration by mass. This is done by distillation under reduced pressure in a vacuum desiccator over concentrated sulfuric acid. We know concentrated sulfuric acid is a dehydrating agent. And next step is hydrogen peroxide converted to 99%. This concentration is done by distillation under reduced pressure, that is 10 to 15 millimeter pressure at 30 to 40 degrees Celsius. Here the water distills off and we will get 99% hydrogen peroxide. From this we will get 100% hydrogen peroxide by the remaining water is then frozen out and we will get the pure hydrogen peroxide. How we can explain the strength of hydrogen peroxide? Strength of hydrogen peroxide is explained by the volume of oxygen at STP that one volume of hydrogen peroxide gives on thermal decomposition. Strength of hydrogen peroxide explained only in terms of volume of oxygen liberated from one volume of hydrogen peroxide by thermal decomposition. 30% of solution of hydrogen peroxide means 30 gram of hydrogen peroxide in 100 ml of solution. This solution, 30% solution of hydrogen peroxide, marketed as perhydrol. The name perhydrol. 1 liter perhydrol give 100 liter oxygen at standard temperature and pressure. Structure of hydrogen peroxide. Hydrogen peroxide has a planar structure. XRD studies, that is X-ray diffraction studies, shows that the 4 atoms, that is 2 hydrogen atoms and 2 oxygen atoms, lie distributed in 2 planes, resembles an open book. The 2 oxygens can be regarded as lying on the spine of the book. Here the oxygen atoms are at the spine of the book and the 2 hydrogen atoms are lie in the open pages of the book. And here in the gas phase, the two oxygen atoms can be, as lying on the spine of the book, kept opened at a specific angle, that is the dihedral angle. That is, in the gas phase it is shown as 111.5 degree, and in the solid phase the dihedral angle is about 90.2 degree. And in the case of hydrogen atom, each lies on the two open pages of the book, making an angle with the oxygen atoms forming. In the solid phase it is about 101.9 degree, and in the gaseous phase it is about 94.8 degree. This difference is because of its forming intermolecular hydrogen bonding causes the association of liquid hydrogen peroxide than that occur in water. Physical properties of hydrogen peroxide. Anhydrous hydrogen peroxide is a pale blue viscous liquid. It has a bitter taste. Its density is 1.45 gram per centimeter cube at 25 degrees Celsius. This high density is due to its intermolecular hydrogen bonding. The dipole moment of hydrogen peroxide is 2.1 dpi. It is soluble in water. Melting point of hydrogen peroxide is about minus 0.7 degrees Celsius, and boiling point is 85 degrees Celsius at a pressure about 66 millimeter. Chemical properties of hydrogen peroxide. We are discussing decomposition, reaction, acidic nature of hydrogen peroxide, oxidizing action of hydrogen peroxide, oxidizing action in acidic medium and in basic medium, and its bleaching action, reducing properties in acidic medium and in basic medium, and some addition reactions. First reaction is decomposition reaction. Pure hydrogen peroxide decomposes on heating to yield water and oxygen. But being not very stable, it decomposes on even standing. When we are keeping in the glass bottles, it will contact with the rough glass surface and can accelerate the decomposition reaction into water and oxygen. So, hydrogen peroxide is kept in or stored in paraffin wax bottles or plastic bottles. This decomposition reaction can be accelerated by several chemicals like alkali or finely divided metals such as iron, copper, cobalt, gold, silver, platinum, etc. Metal ions like ferrous, metal oxides like manganese dioxide. Even dust or light can accelerate this decomposition reaction. Next one is its acidic nature. Hydrogen peroxide decomposes in aqueous solution and exists as a dibasic acid. Its proton and hydroperoxides. It can also decompose form proton and peroxide. So it forms two series of salts, hydroperoxides and peroxides. For example, sodium hydroxide treated with hydrogen peroxide, we will get sodium hydroperoxide, and also here we will get sodium hydroperoxide, and in this case we will get sodium peroxide. So hydrogen peroxide will give two series of salts by the decomposition reaction, or in taking in aqueous solution it will decompose as proton or hydroperoxides or proton or peroxides. Oxidizing action. Hydrogen peroxide is a powerful oxidizing agent, and that means an electron acceptor in acidic and alkaline medium. That is, in acidic medium, hydrogen peroxide will accept electron and H plus to form. H plus is the acid medium and giving water. In basic medium, hydrogen peroxide accepts electron and giving hydroxide ion. Some examples of oxidizing reaction in acidic medium. First reaction, it oxidizes ferrous sulfate to ferric sulfate. That is, when treated with ferrous sulfate in presence of acid, it will give ferric sulfate. Here Fe2 plus, here Fe3 plus. Hydrogen peroxide oxidizes lead sulfide to lead sulfate. In this case, hydrogen peroxide oxidizes lead sulfide to lead sulfate. This reaction forms the basis of restoring the white color of lead paintings that have blackened due to the formation of lead sulfide as a result of lead sulfide present in air. Hydrogen sulfide in air. On treatment with hydrogen peroxide, the lead sulfide gets oxidized to white lead sulfate and thereby the white color get restored. Next reaction, it oxidizes potassium ferrocyanide to potassium ferricyanide. That means hydrogen peroxide in acid, potassium ferrocyanide. Here oxidation state of ion is Fe2 plus and here it converts to Fe3 plus, potassium ferrocyanide. Another oxidizing action in acidified solution of hydrogen peroxide with some compound. In this, potassium iodide treated with hydrogen peroxide in acidic solution, it will liberate iodine. Oxidizing action in basic medium. It oxidizes sulfides, nitrides and arsenides to sulfates, nitrates and arsenates in alkaline medium. Here the potassium nitrate, nitrides to potassium nitrates, and here the arsenides to arsenates, and another reaction is sulfides to sulfates, sodium sulfide to sodium sulfate. It oxidizes manganese salts to manganese dioxide. That is, in basic solution, manganese sulfate is converted into manganese dioxide. In that, manganese is in the +2 oxidation state. Here manganese in the +4 oxidation state. And it oxidizes ferrous salts to ferric salts. That is, ferrous sulfate treated with the sodium hydroxide. Hydrogen peroxide is added to this, then ferric hydroxide is formed. Ferrous to ferric. It oxidizes chromium salts to chromates. That is, in chromium sulfate, which is converted into chromates. It oxidizes formaldehyde to formic acid. That is, formaldehyde is oxidized to formic acid in the presence of alkali. We usually take this as a sodium formate. The actual product which on acidification gives formic acid. Next reaction is bleaching action. When colored matter oxidized by hydrogen peroxide, we will get colorless oxidized matter and water. And the other chemical property is its reducing properties. In acidic medium, it reduces to, will give 2 electron. This electron is responsible for its reducing properties. That is, act as an electron donor. In alkaline medium, it also acts as an electron donor. Reducing action in acidic medium. In acidic medium, potassium permanganate solution converted into, here potassium permanganate that is converted into potassium sulfate. Its pink color of the solution is discharged. Here the permanganate ion is reduced to manganese ion. Here manganese sulfate is formed. It reduces the acidified potassium dichromate solution. As a result of this reaction, and the orange color of the potassium dichromate changes to green due to the formation of chromium sulfate salt. It reduces the manganese dioxide to manganese sulfate. Here Mn4 plus to Mn2 plus. It reduces chlorine to HCl. Chlorine is in the 0 oxidation state. Here it is in the -1 oxidation state. Reducing action in basic medium. It reduces halogen to halide ions. When we take chlorine in presence of an alkali, here it is used to potassium hydroxide, so potassium chloride is formed. Iodine, here it is used to sodium hydroxide, sodium iodide is formed. So what alkali is taken with the hydrogen peroxide with the halogen, that corresponding alkali metal halide is formed. It reduces the potassium permanganate to manganese dioxide. Here the potassium permanganate to manganese dioxide, and it reduces the potassium ferricyanide to potassium ferrocyanide here. Here it is Fe3 plus, it is converted into Fe2 plus, and some addition reactions. It involved in some addition reactions. Hydrogen peroxide adds to alkenes to glycols. Here ethylene reacts with the hydrogen peroxide to form glycols. Hydrogen peroxide also form addition compounds with some inorganic compounds. For example, ammonium sulfate, NH4 twice SO4 ammonium sulfate, which is an adduct with hydrogen peroxide, that is NH4 twice SO4 with the H2O2, which on reacts with the water will give hydrogen peroxide. So some it also form addition compounds with some inorganic compounds like ammonium sulfate as well as sodium hydrogen phosphate. So these are some important reactions of hydrogen. Uses of hydrogen peroxide. Hydrogen peroxide used as hair bleach, bleaching agent for textiles, paper pulp, and it also used for the bleaching agent for oils, fats, etc. It acts as a mild disinfectant that can remove the bacteria or any microorganisms, and it is also used in antiseptic in medicine for washing wounds, ear and teeth. Hydrogen peroxide used as an anti-clot to destroy the residual hypochlorite or chlorine after chlorine-based bleaching of textiles. An antichlor is a substance used to remove the hypochlorite or decompose the hypochlorite or chlorine after chlorine-based bleaching in order to prevent the ongoing reactions with and therefore damage to the material has been bleached. It is used for restoring the white color of lead paintings. We have already seen the lead sulfide is converted to lead sulfate. We know lead sulfide is a black and which treated with the hydrogen peroxide or washed with the hydrogen peroxide, it will convert it to lead sulfate, that is white. Used as the propellant for or fuel in rockets, submarines and torpedoes. It is also used in the environmental chemistry and green chemistry because it can be used without causing any pollution, as the products resulting from its use are only water and oxygen. When we are using in any reaction with the hydrogen peroxide, the only byproducts of this, we know hydrogen peroxide is decomposes to water and oxygen. So this is not harmful to environment. So it is a green chemistry based product or without causing any pollution. It is also used for in the restoration of aerobic conditions to sewage waste, pollution control treatment of domestic and industrial effluents. And it is also used for the manufacture of many chemicals such as sodium perborate, PBS, and sodium percarbonate, and also used for the synthesis of hydroquinone and tartaric acid, and also used for the manufacture of propylene oxide and polyurethanes. So it is also used for manufacture of many chemicals, and it is also used in the restoration of aerobic conditions to sewage waste. Hydrogen peroxide reacts with certain diesters such as phenyl oxalate ester to produce chemiluminescence. This application is most commonly encountered in the form of glow sticks. Some horticulturists and users of hydroponics advocate the use of weak hydrogen peroxide solution in watering solutions. Its spontaneous decomposition releases oxygen that enhances the plant's root development and helps to treat root rot and that is cellular root death due to lack of oxygen. So by this hydrogen peroxide decomposition, oxygen enhances plants root development and a variety of other pests. Hydroponics is a type of horticulture and a subset of hydroculture, which is a method of growing plants without soil by using mineral nutrient solutions in a water solvent. Tooth whitening or tooth bleaching is the process of lightening the color of human teeth, and hydrogen peroxide is the active ingredient for most commonly used in whitening products and is delivered as either hydrogen peroxide or carbamide peroxide. Sodium percarbonate, which is an adduct of sodium carbonate and hydrogen peroxide, is the active ingredient in such laundry products such as OxiClean and Tide laundry detergent, which when dissolved in water it releases hydrogen peroxide and sodium carbonate. By themselves, these bleaching agents are only effective at wash temperatures of 60 degrees Celsius or above, and so often are used in conjunction with bleach activators, which facilitate cleaning at lower temperatures. Thank you for hearing me about hydrogen peroxide, its preparation, properties and structure and uses.